Before moving on to our later sections in Chapter 7, I want to take a minute to review how to multiply, divide, add, and subtract fractions. So let's look at our first example of multiplying fractions. Here we have 2/3 times 5/4. To multiply fractions, you multiply the top parts and multiply the bottom parts. So on the top, 2 times 5 is 10. On the bottom, 3 times 4 is 12. And after multiplying, you look to see if you can reduce it. Here, 10 and 12 are both divisible by 2. So you would divide them both by 2 and you get 5/6. Well, let's say we had the fractions x over x plus 3 times x minus 2 over x plus 1. When you're multiplying fractions, you multiply the top parts. So we would have x times x minus 2. Then we multiply the bottom parts, x plus 3 times x plus 1. Now in this case, as we've seen from earlier on in this section, it's actually better to leave it factored like this. When it's factored, you can see whether or not it can be reduced. Here we can see that it can't be reduced. There's nothing we can factor out of the top and the bottom, so that would be it. That would be your answer. Next, let's talk about dividing fractions. Suppose we have 2/3 divided by 5/4. The first thing you do when you're dividing fractions is to leave the first one alone and you flip the second fraction. So instead of 5/4, we would have 4/5, and you change it to a multiplication problem. So to divide fractions, you leave the first one alone, change it to multiplication, and flip the second fraction. Then you multiply. On the top, 2 times 4 is 8. On the bottom, 3 times 5 is 15. So 8/15 would be our answer. Let's try that with our variable fractions. Again, to divide, you leave the first fraction alone, just the way it is. You change it to multiplication. I'm going to put a dot instead of x to make it less confusing. And you flip the second fraction. So instead of x minus 2 over x plus 1, it's going to be x plus 1 over x minus 2. Now on the top, we multiply, we would have x times x plus 1. On the bottom, when we multiply, we would have x plus 3 times x minus 2. Like that, and that would be your answer. Adding and subtracting generally are going to take a little bit more work than multiplying or dividing when it comes to fractions. And the reason is, unlike multiplying and dividing, when you're adding or subtracting, you have to have a common denominator. Now, you don't have to have the least common denominator, you just have to have a common denominator. So the easiest way to get a common denominator is to multiply each fraction on the top and the bottom by whatever's on the bottom of the other fraction. So for example, in this problem, 2/3 plus 5/4, I'm going to multiply the 2 and the 3 both by 4. So I multiply 4 by each one of those. For the 5/4, I'm going to multiply each of those by 3. You multiply the top and bottom of each fraction by whatever's on the bottom of the other fraction. And when we do that, for the first fraction, 4 times 2 is 8. 4 times 3 is 12. For the second fraction, 5 times 3 is 15. 4 times 3 is 12. And now that you have a common denominator, you leave it alone. The bottom number, when you add or subtract fractions, doesn't change. Once it's a common denominator, it just stays the same. You only add or subtract the top parts. And here, 8 plus 15, we would get 23/12. Having done that, let's look at a similar example using x over x plus 3 plus x minus 2 over x plus 1. First, I like to put parentheses around all these things with more than one term, or just put it around all, just to make it easier to look at. Now, to get a common denominator, we're going to do exactly what we did with that example over there to the left. we multiply the top and bottom of the first fraction by what's on the bottom of the second fraction. In this case, it's x plus 1. We multiply the top and bottom of the second fraction by whatever's on the bottom of the first fraction. In this case, it's x plus 3. So when we do that for both fractions, our denominator now is going to be x plus 1 times x plus 3. We've got our common denominator now. And it's on the bottom part, leave it separate. Don't multiply them. Just leave it like that. That makes the later steps a whole lot easier. But the top parts, you do want to go ahead and multiply. We distribute x plus 1 times x. X times x is x squared. 1 times x is 1x. Then for the next part, we have to use the FOIL method. X times x is x squared. X times 3 is plus 3x. Negative 2 times x is minus 2x. And negative 2 times 3 is minus 6. Like that. So now, when you're adding fractions that have a common denominator, you leave that denominator alone. Just x plus 1 times x plus 3, and you add the top parts. So we're just going to have x squared plus 1x plus x squared plus 3x minus 2x minus 6. Then we need to combine all those like terms on the top. So x squared plus x squared is 2x squared. 1x plus 3x minus 2x, let's see, that's going to be plus 2x. And then we still have a minus 6 there at the end. All right. Now the trick with adding and subtracting these things is you have to factor the top part to see whether or not it can be reduced. So on the top part, to factor it, we would need to factor out a 2. All the terms there are divisible by 2. Getting messy here. And we would have 2 times x squared plus 1x minus 3. Like that. On the bottom, we have x plus 1 times x plus 3. Now, if we could factor that last parentheses, we would, but there's nothing you can multiply to get a negative 3 that adds up to a positive 1, so we can't factor it any more than that. Now, looking at this, there's nothing that's a factor on the top and the bottom, so we can't reduce it. That would be the final answer. So, you'll notice adding and subtracting problems do take a lot more steps than multiplying or dividing. Let's take a look now at the same fractions, but subtracting. We already up above showed that for 2/3 and 5/4, when you multiply the top and bottom of the first one by 4, you get 8/12. When you multiply the top and bottom of the second one by 3, you get 15/12. There's our common denominators. And to subtract, we just subtract the top parts. 8 minus 15, you would end up with negative 7/12. In the same way, looking at this next one, it's very similar to the previous problem. If you multiply the top and bottom of that first one by x plus 1, we got x squared plus 1x over x plus 1, x plus 3. We have a minus in the middle. And for that second one, when we multiplied out the top and bottom by x plus 3, we got x squared plus 3x minus 2x minus 6 over x plus 1, x plus 3. Now, when you're subtracting fractions with a common denominator, boy, I can't draw a straight line. That's embarrassing. The bottom part stays just the way it is. It's just x plus 1, x plus 3. A lot of people make mistakes on these subtraction problems. Everything from the top part just stays the way it is, x squared plus 1x. But notice you are subtracting this entire top part. So what that means is you need to take this minus sign, think of it like it's a -1, and distribute it to every term on the top of that next fraction. So instead of a positive x squared, that's going to be minus x squared. Instead of plus 3x, it's minus 3x. Minus -2x is plus 2x. Minus -6 is plus 6. So when you're subtracting fractions in this chapter, after you get a common denominator, distribute the negative sign to the top of the second fraction. Then we combine like terms. X squared minus x squared, they're opposites. They just cancel out. 1x minus 3x plus 2x, well, that ends up being 0x. So they all cancel out too. So the only thing we have left on the top is 6. And on the bottom we have x plus 1 times x plus 3. We're going to spend a lot of time in our upcoming sections of Chapter 7 looking at adding, subtracting, multiplying, and dividing rational expressions.